From the heavy steel giants of the past to the cutting-edge technology of tomorrow, tanks have been a cornerstone of modern warfare for over a century. But with the rise of drones, missiles, and AI, are these iconic war machines still fit for the future battlefield? In this video, we'll dive into how next-generation tanks are evolving, becoming lighter, smarter, and more deadly, with revolutionary new technologies that could change the way wars are fought forever. Could Tesla-inspired tech and autonomous systems make traditional tanks obsolete? Stay tuned to find out how the battlefield of the future is being reshaped by innovation. Russian missiles are making US tanks obsolete, but Tesla-inspired tech could change everything. The Cold War has been over for 30 years, but you wouldn't know it by looking at the world's tanks today. The armored fighting vehicles of the 1970s and 1980s are still around. America's M1 Abrams, Russia's T-72 and T-80, Germany's Leopard 2, Britain's Challenger, and Israel's Merkava. These machines may have been upgraded over the years, but today's tanks would still look and feel familiar to a Cold War-era tanker. But time catches up with all things, even 70-ton steel beasts built to withstand the blast of shells and rockets. By 2050, a new generation of tanks will replace the vehicles from the days of Ronald Reagan's administration. The new tanks won't be totally unfamiliar. They will probably look like today's vehicles with rotating turrets and caterpillar tracks. There may also be a family resemblance. Instead of incurring the huge expense of developing and manufacturing a brand new design, nations such as the US and Germany are building from existing models. Nonetheless, tanks in the mid-21st century will have plenty of new features. They will be smaller and lighter, and thus more mobile and easier to transport by air or sea. They will have hybrid or electric engines, launch their own drones, and have defensive systems to stop enemy drones. They will also be highly digital and automated, including extensive reliance on artificial intelligence. This means incorporating advances in energy systems, armor, camouflage, and other protection technologies, onboard sensors, digital battle management systems, and improved firepower, says James Black, Assistant Director for Defense at the RAND Europe think tank. It also means AI and autonomy, both in terms of automating more of the tasks of a tank crew and in terms of pairing crewed vehicles with uncrewed ground or air systems to fight as a system of systems. For a glimpse of the future of tanks, just look at today's automobiles. Civilian cars and trucks are increasingly digital, with software an integral part of the vehicle, from entertainment to collision avoidance systems. The next generation of tanks will have to mimic some of the design philosophies of Tesla, says Mick Ryan, a retired MHJ with the Australian Defence Force. The main battle tanks will need to be a computer program around which we wrap a vehicle. They must have open architecture and rapidly upgradable digital systems. When World War II began, in 1940, tanks weighed as little as 5 tons. Today, the Monitor version of the Abrams tops the scale at around 70 tons. This enables the Abrams to pack an impressive amount of firepower and armor, but heavy vehicles chew up paved roads, get stuck in mud, and are hard to transport to the battlefield. The Abrams tank can no longer grow its capabilities without adding weight, and we need to reduce its logistical footprint, Maj Gen. Glenn Dean, the U.S. Army's Program Executive Officer for Ground Combat Systems, said in 2023. The transportability aspect is particularly crucial for expeditionary nations such as the US and Britain, who fight their wars on foreign shores, meaning their armored vehicles must be hauled by scarce cargo planes and ships. Next-generation main battle tanks will need to be more strategically deployable while also being tactically survivable, explains Ryan, who commanded an Australian mechanized brigade. This means they will have to be lighter and able to be rapidly moved by air, sea, and land. The U.S. Army's current plan for a next-generation tank is to develop a lighter version of the Abrams. This trend can already be seen in more recent tanks, such as South Korea's K2 Black Panther and Japan's Type 10, which weigh around 50 to 55 tons. Advances in engine technology may help to further slim down future designs. The Achilles heel of tanks has always been fuel consumption. Many armored offensives, from the German Blitzkrieg in Russia to the Allied breakout from Normandy, achieved brilliant success initially, only to grind to a halt as the tanks ran out of gas. As tanks have grown heavier over the last century, so has their thirst for fuel. The epitome of the armored gas guzzlers is the M1 Abrams, a highly capable vehicle that eschewed the traditional diesel engine in favor of a powerful gas turbine power plant that offers high acceleration and horsepower. But the fuel consumption of the Abrams is a staggering 3 gallons per mile. That's taxing enough for the US Army with its ample supply system, but for less logistically well-endowed users like Ukraine, keeping tanks refueled is a crucial concern. Fuel trucks are vulnerable, and mud and rough terrain hamper wheeled supply columns. This has spurred armies to find ways to reduce the logistical burden of armor. One solution is a hybrid electric engine, the same concept as those found on consumer vehicles like the Toyota Prius, that combine a diesel power plant with an electric motor and batteries. In addition to improved fuel consumption over purely gas or diesel engines, a hybrid motor would mean better mechanical reliability, a quieter engine less likely to alert the enemy, and a lighter vehicle overall. The fuel consumption of the Abrams is a staggering 3 gallons per mile. The next generation Abrams will likely be equipped with a hybrid engine. Defense manufacturer General Dynamics has already shown how with its Abram X technology demonstration vehicle, which is powered by a diesel-electric power plant that uses 50% less fuel than the current gas-powered Moni, according to the company. And future tanks will need all the electricity they can get. The power requirements for new generation main battle tanks will be much larger, and therefore, we need better vehicle power and power management systems, Ryan says. Beside the need to power all the traditional things like turret, gunnery, and sensor systems, vehicles will need the power for defensive systems as well as the ability to be a recharge station for uncrewed ground vehicles. As for purely electric tanks, that probably isn't feasible yet. Running out of juice in the middle of a battle is a problem, as is finding a recharging station on the battlefield. Tank cannons have become larger and more powerful throughout the years. During World War II, tanks typically sported calibers of around 75mm, followed by 9 tim and 105mm rifled guns during most of the Cold War. By the 1980s, Western and Soviet tanks were mostly armed with smoothbore cannons of around 120mm, which remains the standard today. But the next generation of tanks may be armed with bigger guns. The main ground combat system, a joint French-German initiative to develop a main battle tank by 2040, may be armed with a 100 Fordham cannon. In the 1980s, the US Army also experimented with a 100 Fordham Abrams gun. New tanks will probably be equipped with auto-loaders, which replace the human loader with a mechanical system to feed the cannon. This enables tanks such as Russia's T-72 to reduce crew size from 4 to 3, thus enabling a smaller and lighter vehicle. Critics say that autoloaders aren't as reliable as a human, which is one reason that some tanks, such as the Abrams, Challenger, and Merkava, have a fourth crewman to load the gun. But the push for slimmer tanks means autoloaders will probably become standard. Tanks have usually comprised a revolving turret mounted on a tracked chassis with 4 to 5 crew since the 1920s. Depending on the design, the majority of the crew, commander, gunner, and loader, if no autoloader is fitted, would be in the turret, with the driver in the more heavily armored hull. The turret made a smaller target than the hull, but if hit and penetrated by a shell or missile, the results could be catastrophic. The next generation of tanks will have a very different layout. The turret will be automated, while the crew will be safely nestled in the hull. That's the approach Russia has taken with its T-14 Armata, whose appearance at a 2015 military parade in Moscow startled Western analysts. The Armata's 3-person crew operates the tank from an armored capsule inside the hull and operates the turret by remote control. This approach is somewhat reminiscent of the assault guns of World War II. These were essentially tanks without a turret, with the cannon mounted in the front and the crew inside the hull. Though they were cheaper than tanks, the lack of a rotating turret and a fixed traverse gun meant the entire vehicle had to pivot to engage targets. But technology, such as computerized displays and AI, will enable next-generation tanks to have the best of both worlds: a traversable turret and a well-protected crew. Survivability for crewed main battle tanks and other armored vehicles will be important, Ryan explains. This may drive more uncrewed turrets on crewed vehicles. Despite the awe created by big fire-powered metal beasts, tanks have never been invulnerable. They have fallen victim to anti-tank missiles, handheld rocket launchers, mines, artillery shells, and bombs. This has led to multiple pronouncements that the tank is dead, most recently in Ukraine, where cheap drones have picked off armored vehicles. This eulogy is premature. A variety of defensive countermeasures will protect next-generation tanks. Active protection systems such as Israel's Trophy use radar to detect incoming anti-tank rockets and then employ jammers and smoke grenades to deflect these munitions, or even fire small projectiles to shoot them down. The problem with fitting active protection systems to existing vehicles is that they add additional weight. But from the outset, new tanks will be designed to incorporate defensive countermeasures against rockets. So right now, as for defense against drones, which have proven lethal to armored vehicles in Ukraine, future tanks will be equipped with jammers to disrupt unmanned aerial vehicle UAV guidance systems. Next-generation tanks will also become harder to detect. Whatever the next generation of tanks will look like, they will be expressly designed to operate with drones, or even launch their own. Manned tanks will be supported by a variety of scout and attack robots, both in the air and on the ground. Manned-unmanned teaming for aircraft and helicopters has already generated a lot of buzz. The US Air Force intends to build a fleet of combat drones, which resemble small jet fighters, to support the F-35 man fighter. Australia is pairing jets and drones in its Loyal Wingman project, while the US Army has tested coupling AH-64 Apache attack helicopters with tactical UAVs. The same process is underway for armored vehicles. Defense contractor General Dynamics, for example, has developed a variant of the Stryker called the Stryker X that is armed with 4 Switchblade kamikaze drones. And there are plenty of robots that can serve as bodyguards and consorts for tanks. For example, T-Hemis Tracked Hybrid Modular Infantry System from Estonian firm Milrem Robotics is a 2-ton tracked, remote-controlled robot that can be armed with anti-tank missiles, a 3rd-M cannon, or machine guns. Almost 200 tanks were built during war, including 6 1000 American vehicles. Today's models are simply too complicated and expensive to manufacture at that scale, but the heavy tank losses seen in the Russo-Ukrainian War, including 8,000 Russian tanks destroyed in just 2 years, is a stark reminder that nations can't afford the luxury of buying just a few tanks, no matter how sophisticated. Next-generation tanks won't be mass-produced as in World War II, but they will be designed to be upgradable, with open architecture to allow easy improvements to software, sensors, and other components. The fact that Cold War vehicles are still around shows the tank is far from dead, and the next generation of tanks may have an even longer life.